Hello everyone, today I will explain regarding my research with the title is a PSO Implementation for Supplementary Control or PID Control in DC motor system. So we already know PSO is particle swarm optimization. So in this research I want to apply particle swarm optimization in through PID control in DC motor system. So this presentation for Professor Licky Baek class, and I hope you enjoy this presentation. So in this slide, we will discuss about several outline. First, we need to know DC motor control system description regarding PID control also how to process tuning PID control, including the several optimization through PSO algorithm. In this slide, we will discuss first about DC motor control system. DC motor is continuous actuator that converts electrical energy into mechanical energy. Usually, DC motor widely used in industrial application where wide speed range are required. So it means the several speed it's required, and it means we need to control speed range. And there are several control like usually that can be used is PID. As you can see in the last description, PID control are probably the most commonly used for a controller. And this is as in the right figure, you can see there is a PID DC motor controller block diagram, which refer to this reference study. In this slide, we will discuss about PID control. So dynamic of the system cannot be changed by the designer to improve system performance. So we need controller, which is the aim of controller is to generate control allow you to enable the system to achieve desirable performance. So the tuning of PID control, usually there are three reasons why we need to tuning PID control. First, it's very simple in use and available everywhere, and it has a successful history. So PID control is important because of that reason. So the other part, how the process tuning. So the design, the key of the control is to find the right value of adjusted parameter within each controller. As you can see, there are three control parts in PID: first proportional, integral control, including the derivative control. So the selection of this parameter is based on trial and error. Is usually like that. So it will become problem because it takes a long time and we don't know the result of performance. So using the PSO, it will be helpful for the user or another designer, because through PSO it can help the solving time and also improve the performance. In this slide, we will discuss the regarding optimization problem. So as you can see in this part, the optimization problem, we need to know the definition. Optimization problem, it means finding the best solution among the set of all feasible solutions. As you can see here in the figure, there is a several of iteration, which is this iteration, it depends on the objective function value. So in this PSO, for this implementation code, we applied the integral of absolute error to define which is the best solution to get the tuning of PID process. And so what is the PID process parameter? Like we already discussed before, there are three main parts of PID control: first, proportional gain, integral gain, and derivative gain. And the other part, the other part that is also important is search space. Search space, it means how the maximum range value between 0 until another value. That means the variable to vary the gain value. Okay. Uh, Before we discuss more advanced regarding PSO, we need to know about how tuning process in PSO. As described in the right figure, a search technique of PSO is based on computing to find near optimal solution to optimization problem. Because PSO is swarm optimization, it means they need population, because the
spiral of movement is based on nature, social behavior, and dynamic movements with communication of insects, beasts, birds, and fish. Use of number of particles or population that already uh, told in the previous slide. It means each particle's insert space adjusts its flying. So first we can setting the search space value in the code for initialization, and then another particle value will adjust that optimization will adjust that performance based on optimization value. So there are several key terms parameter in PSO. First, we already did know that PSO is swarm optimization. It needs particle. Besides, population is also needed because they don't work alone. So they need a population, and then search space. Search space it means the all possible solution to the problem, such as parameter in PID control. So we will discuss about more further in the next slide. And each particle is assumed to have two characteristics. First, position. We can define it based on xi in here in the figure, and then another is a velocity. So we can get the distance and then the velocity of each particle in order to consider the in order to consider uh, based on individual movement and global movement, we have the personal influence value P base here, and another value is global influence based on G base. So using that two value, we can get the value of we can refer to the optimization based on each iteration until termination time is met. So in first of all, to get the initial setting of PSO, we need to know initial population number of particles. This is very important. And then initial position, also initial velocity. So, and then I already discussed in the previous slide, because we also consider the individual movement and the global movement based on which is it means in the term of view of individual particle to the global particle, G base is used. So this P base and G base is optimized based on objective function, and we can get the value of velocity and position for each particle are updated according to the equation. So according to equation number 2 and number 3, we can get the value of velocity and distance. So I already discussed how to stop the iteration. So what is the parameter? So the parameter that we can stop the iteration or learning process, it's called as termination. So through this termination parameter, we can iteratively repeat it until the maximum number of generation is reached or a termination criterion is met, or we could easily is based on the iteration value that we can setting in the initial parameter. Okay, so parameters that required from user to define the PSO: first, population size, initial population and initial velocity, inertia weight, the individual and social cognitive C1 and C2. We will discuss like in the before in the previous slide. There's also individual and social cognitive in the velocity equation, and then uniformly distributed random numbers, so include which start from range 0 until 1. In another part is termination critical number of iteration t. So okay, let we discuss in the based on right figure. So it starts from iteration from 0 until the high iteration, but we can see the movement and the movement is similar with the insect, which we can see that there's a distribution part and then they move to converge part. So as you can see, until the very high iteration, the movement of PSO, it seems very good because they optimize their value uh, based on it based on the objective function. So Okay, let's discuss in the next slide. So in order to describe the PID control in DC motor system, we can easily use the MATLAB simulation. So in here I put the first, we need to know the transfer function system, which is based on numerator and denominator system. We already discussed in the first slide how to define numerator and denominator based on reference paper study. So in here we can discuss, first of all, we need to setting the transfer function of closed loop and open loop system in MATLAB. So based on NS and DS parameter. So after we get the setting value, we need to know, we need to setting the value of PSO optimization, particle swarm optimization. So we already discussed about the C1 and C2, weight inertia, how much particle or population, including the time iteration part. In other, search space is also used that I already discussed. So usually we can, I already make a rectangle area in this part. It means a search space is also helpful for defining the PID control. So as you can see here, AEB, it defines in parameter X, and X parameter it used to define the KP, KI, and KD. In order it is just the simplified things, for the detail explanation I already discussed how the PSO works. So based on this parameter, it means PID control is depends on the value of search space and another value of another parameter like PA, uh, like a random value, and this KPKI and the KD always change to get the optimization value based on objective function. So we already discussed about the equation of time integral absolute error, and then we can amplify them into MATLAB code. So this is the result of step response between original system and after we use PID control. As we can see, in original system, PID control is very slow to get the steady state value in order the different gain margin as occur. So using the PID control, it which have the fast response, also the gate with the better margin for the response. First we can see through the amplitude value, and then we can see the time integral absolute error which each iteration is applied. So uh, until the last iteration, it will be good because we need to minimize the time integral absolute error, and it works well, which is the until the very last iteration it will be decreased. Okay, that's all. Uh, Thank you very much for your attention, and if there is any question, please comment in the YouTube channel.